Hello, greetings 11 and 12. This is Lucky Math. So, now I am your tutor for math under our program. So, now we are unlocking one of the biggest ideas in all of math, which is functions. So, guys, imagine if math was a machine, function would be something like the engine inside. Mhm. Did you notice that, like, you've been doing functions all the days of your life, but you never realize that you're doing functions? Example being what? Imagine you bought 20 rand airtime and you get 1 gig. That's a function, guys. So at the moment that you input that 20 rands and you get 1 gig, that's a function. So you input one value, you must get one output. Or if you get two outputs, that machine is simply broken. So, or another one can say that when you input two or more inputs, you must get only one output. That's all. That is a simply of what function is. So today, no fear, no confusion. We are going to be doing step by step, line upon line. By the end of this session, you will be able to spot a function, define it properly, and draw it like a pro. So now all you have to do is just that go and grab that pen of yours, grab that scribbler of yours, and let us do it together. So in Lucky's Math, we are not just going to learn, we are just going to comprehend what functions are. So let's go. What are functions? Functions is the special relationship between the input x value and the output y value, where you input one input or two, you get the finite output value. That's the definition of the functions. So you just have to know it. There's no way they are going to ask you about what functions are in math. There's no theory in math. You just have to learn about it. So let's continue. Now we are going to start with the linear functions from grade 10. Yeah, the linear functions from grade 10. So I'd like you to know uh linear function is a straight line graph whereby you substitute one input x value, it gives you exactly one output value. That's a function. That's the linear function is. So let's continue. Now let me give you the examples in grade 9 that you did about the linear functions. In grade 9 you learned something like this. It was something like this table. They said here is x and here is y. So they gave you something like this. They said this is 1, 2, 3, 4, 5. Here they can say maybe dots, and here they can say maybe 7. Yeah, something like this. So here maybe they said 2, 3. Okay, let me not say 2, but let me just do the multiples of 2. 2, 4, 6, 8, 10. And here they can say it's okay, because we don't know the number, we just put the dots. Yeah, I think something like this. Yeah, let me just put something like this. So now the question is, they've given you all the terms on the table. They've given you the necessary information that they need to give you so that they can ask you a specific question. So now you have to determine, what do I have to do to get the next term? So example being that from term number 1, term number 2, term number 3, term number 4, 5, whatever that is in the middle, and term number 7. So they didn't give you this value up here. They didn't give you this value up here, and they said that you must determine what is that value. So what are we going to do? So actually you got the number right here. So first thing was to figure out, what do I have to do here? So what do I have to do? Okay, now you have to determine what is the difference between my terms here, because they've given you okay, 1, 2, 3, 4, 5, whatever, and 7. And below here, they've given you 2, 4, 6, 8, 10, whatever, and the question that they want to ask you. So let us determine now what our terms could be. They've given you these values up here. They've given you these values up here. Now, what are those values called that I've marked in a red pen? What are them called? Those values, they are called independent values. They are independent. When the question comes, they give you those questions. They give you those values actually. So when they give me those values, I must determine what are the dependent then. So they depend on the independent values. So the ones that I mark in green right now, these ones are my dependent ones. So I want to know, how do they get my dependent values? So this is what we are going to do now. You can see that this is a pattern actually. This is a pattern. So you see that this is a pattern. So what is the difference between my independent values? So my difference here, you see that is 1. My difference here, you see that is 1 also. So throughout is going to be 1. So you see that also here must be 1. So you see that when you came over here, you know, okay, that okay, my difference is the same all throughout. It means that here my difference is 1. So what must I do to get this value up here? So it means that I must add 1 to the previous value so that I can get 1 to the next value. So when you add 1 on 5, it means that you're simply gonna get 6. I hope I'm understood there. So here below, you do the same thing. What is the difference between my terms? The difference is 2 all throughout. The difference is 2. You simply say that 4 minus 5 minus 2, you get 2. 6 minus 4, you get 2. 8 minus 6, you get 2. And 10 minus 8, still you get 2. So you see that from here to here also you must get 2. And from here to here also you must get 2. So now if I add 2 to 10, what must I get? It means that I must get 12. If I add 2 to 12, what must I get? I must get 14. That's simply how function is. I hope you understood, guys. So this is simply what functions are. So another example, you did it in grade, let me say in grade 7, where they give you something like this, and you never realize something like a spider, and they said simply this thing is a spider. Let me say this is spider diagram. 1, 2, 3, 4. Yeah, this is a spider diagram, and here they can say multiply by 2. Here they can say 2, 4, or here they can skip, and they put 6 here. Yeah. So now they said, what are these terms that we didn't put here? And they can give you this one, and they can say that, let me put 10 here. Yeah, let me put 10. Yeah, let me put 10 here. So, yeah, they say realize, determine the ones that are missing here. Fill up the missing terms. It was the question says in grade 7. Fill up the missing terms. So, now I have to do what I have to do. I have to press my calculator to get the terms here. So if you press your calculator from 2 and multiply by 2, you will get how much? 4. If you press your calculator, 4 multiplied by 2, simply get 8. So now you don't have this term, but you can skip it and go to the next term. So you can say 6 multiplied by 2, you get 12. So now, why do we have the difference here? My teacher once said from this one, when you have the output, which is y, this is the output, guys, and this is the input. This is the output and this is the input. So when you have the output here, you want to get the input, you must do it the vice versa, which is the other way around, from here this to get here. So simply here you cannot say 10 multiplied by 2 and you will get this one. You will get the input, because like if you said 10 multiplied by 2, you're gonna get 20, which is actually wrong, because like 20 multiplied by 2 is not gonna give you 10. It gives you 40, which is more than 10, which is wrong actually, which is wrong. So let me rub it. It is wrong, this one. So what must I do? Because of you are doing it the other way around, it means that you must change the sign here, which is multiply, to divide. This is what my teacher said to me. So when I do it the other way around, it means I must say that, okay, 10 divided by 2 here, it must give me how much? 5. So now, to see that we are fine and we are correct in our statements, let us do it the other way around. When I say 5 multiply by 2, I will get 10. This is simply correct. I hope you understand what functions are. Thank you. So in our linear functions, we were saying that is a straight line graph whereby substituting each input x value, you must get exactly one output. So its general formula in grade 10, they are saying it is y is equal to mx plus c. Y is equal to mx plus c. So now you see, this is your output value. Output value. Yeah, it is your output. This is your input value. I already explained about these ones, how they work. So make sure you understood the example so that you may understand this thing fully. So now they've added something here which is C and M. So now I have to know what is this C and M doing in my formula now. This is the general formula in grade 10 that we have to learn. Just write it on a notebook. It's very important. So why do I say it is general formula in grade 10? Because like in grade 12, you'll find some formulas that you didn't even understand, you didn't even do before, where they say that y is equal to ax plus q, and you don't know what are those things. This is simply thing, they just change the variables. So that is simply what it is. So I hope you understood. So it's gonna be fine. That's a topic for another day when I'm doing it with the group 12. So now, what is M and what is C? Okay, it's not a problem. Let me explain what is M and what is C. My M, when I'm talking about my M, I'm talking about my gradient, the thing called gradient. Now, if I say this is the gradient, what is the gradient doing in my formula? Why do they include things that are complicating? No, it's not complicating. You just don't understand the word term gradient. When we are talking about the gradient, we are talking about the steepness of the line, because we said that my linear function, it is the straight line graph. So the straight line graph, it is either it is steep or it is gentle. So now when I'm talking about my gradient, I'm talking about my steepness of the graph. I hope you understood the thing. So when I'm saying something is steep, I'm saying something is like this. The difference between like this, other one can be like this, other one can be more like this. This is the steepness of the graph, guys. It's the steepness of the graph. It's just changed the shape. You see, the other one is more like horizontally. The other one is more like vertically. The other one is more like diagonally, something like that. You see, is when we are talking about the function. We are talking about the straight line functions. That's it. So that is the gradient we are talking about. So C. Now, question is, what is C? Because I have explained what is M. So C, we are going to understand it more when we are drawing the graph. You will understand more when you are drawing the graph. So C, it is called the y-intercept. Y-intercept. It is more necessary when we are drawing the graph. This one is the y-intercept. You can write it down. I hope I wrote it. My handwriting is not good, guys. I just write it, the y-intercept. Yeah, y-intercept. It is the y-intercept. We will understand it more when we are drawing the graph. So this is where our graph touches the y-axis. So this is where our graph touches the y-axis. You know that you learned about the Cartesian plane, something like this, something like a cross, something like this. So when you draw your graph, is maybe something like this. Let me say you're drawing your graph, and your graph is going to be something like this. It simply says that this, where your graph touches the y-axis, this is the y-axis, and this is the x-axis. This is the x-axis. So where your graph touches the y-axis, it is called the y-intercept. It is called the y-intercept. I hope you understand. So where your graph touches the x-axis is called the x-intercept. The x-intercept. Intercept. Aha, something like this. You see, this is the x-intercept. This is the x-intercept. This is the y-intercept. I hope you understood this one. So let us continue. Now, let us go to the examples. Let me give you the example that I may give you in class when you are doing the linear functions. So linear functions. These are linear functions. Y is equal to 3x plus 4. This is the linear function, guys. So now, this is the example that I may give you as a linear function. So if someone asks you what is the gradient here, so you simply saw that when I was doing my graph, it was about something like this, mx plus c. So you see, in the place of m is where 3 is placed. In the place of c is where 4 is placed. So simply meaning that my 3 is the gradient. My 3 is the gradient, and c is the y-intercept, which is how much? Which is 4. This is the y-intercept. Intercept. So now, if I was about to draw the graph, I was going to do this. I must firstly do the intercepts. I must do the intercepts when I draw the graph. So my first intercept is gonna be the y-intercept. So when you calculate your y-intercept, it means your x must be 0. Understand this. When you calculate your y-intercept, your x must be 0. So now I want you to look very carefully and understand very carefully here. Put your attention here. So put your attention on the slide so that you may understand this. There is no necessity for you to calculate the y-intercept because the statement already gave you the y-intercept. So if the question asks you what is the y-intercept, you simply gonna say y is equal to 4, because this is the y-intercept. So this is how they place the y-intercept. You say y is equal to 4. You do not say c is equal to 4. That is actually wrong. This is how we put our y-intercept. So because I said that c is the y-intercept does not mean that its formula is given by c is equal to 4. Its formula is given by y is equal to 4. That is how it's given. So even for x-intercept, you are going to calculate your x-intercept. You are going to calculate your x-intercept because it's not the same. You are not given it on your formula, the x-intercept, but you simply have to calculate it. So now let me firstly show you how to calculate your y-intercept in case if they don't give you the statement like this. So how did they get the 4? Now that is the question. How did they get the 4? How do they see the 4? So now when they say you must put your x to be 0, it means that whatever in the place of x, it means you must put how much? 0, and you get 4. So simply look at this thing. So you see that in the place of x, I put 0. Now I put 0 in the place of x. So this is what? So when I press my calculator, it's simply gonna say that 3 multiplied by 0, 3 multiplied by 0, or any number multiplied by 0 is gonna give you how much? 0. Simply it. So it's gonna be 0 plus 4. 4 remains. So 0 plus 4, simply 4. This is how they got the y-intercept, guys. Simply understand this. I hope you understood. Now, the next step, we must calculate the x-intercept. Even for x-intercept, when you calculate your x-intercept is vice versa. When you calculate your x-intercept, it means you're gonna put your y to be 0. So look at your formula now. Where there is y, you can say 0. Where there is y, you can put 0. So that is my formula. My formula is y is equal to 3x plus 4. So where there is y, I put how much? 0. So this is how 3x plus 4. Then what do you do now? You do the algebraic expression or the algebraic equations, where you have to say you solve for x. Now you see that this is more simply like you solve for x. So you take this thing to the other way around. You say that is negative because it has crossed the border. Now it is negative 3x is equal to 4. So now what we have to do here, I have to divide both sides by negative 3. Divide both sides by negative 3, and you say that x is equal to 4 over negative 3. Or when you press your calculator, it's going to give you negative 4 over 3. It's the same thing. So this is your x-intercept. Sorry to say y-intercept. It's your x-intercept. So now, how do you write your coordinates for the y-intercept and the x-intercept? So because here you said that you put you know how to write the coordinates, right? So when you write your coordinates, here is simply x and here is simply y. So what did you say your x is? I said my x is 0 when I calculate my y-intercept. My x is 0, and what is your y? My y, it is 4, therefore I put 4. These are my coordinates for the y-intercept. So what are your coordinates for the x-intercept? Because here, let us write it again so that you may understand fully. Because I have put my I put my y to be 0. Where there is y, I'm going to put 0. And what did I say x is how much? I said that x is negative 4 over 3. These are your coordinates when you calculate the x-intercepts. I hope we understood very well, guys. Then remember, guys, you had 2 coordinates there. So let us draw the graph. So when I draw the graph, is going to be I firstly write my coordinates of the x-intercept. So my coordinates of the x-intercept is negative 4 over 3 and 0. Why am I saying and 0? It is because when I say let's calculate the x-intercept, I say let's put y to be 0. That is why my y here is 0. I hope we understand this one. And again, my coordinates for the y-intercept. My coordinates for the y-intercept simply again is the same meaning for the one that we calculate for the x-intercept. It's because we put our x to be 0. That is why here we are going to say that it's okay. I'm sorry. Let me say. That's why we are going to be simply say that our x is 0, then our y is 4. Remember very well. So you see, I have 2 coordinates now. Therefore, I can draw my graph. So let us draw the graph and see. Firstly, you know that you have to start with the Cartesian plane. Use a ruler, please, if you are drawing on your notebook. And again, what we are going to do here, we are going to write 1, 2, 3, 4. You can say 1. Yeah. So we draw 1, 2, 3, 4. Yeah, until 4, 4. Yeah, you just do 4, 4 if you know that. So what you are going to do here is that you are going to write the coordinate. You are going to place the coordinates on top of your Cartesian plane. So let us start. So where is 0 and 4? You know that 0 and 4, it is found somewhere here, if I'm not mistaken. 0 and 4 is somewhere here. Then what is negative 4 over 3? Negative 4 over 3 is simply negative 1,3333 until. So negative 1,33, you found it somewhere here after 1. Yeah, I think so. It's after 1. So these are my coordinates. You see, this is the x-intercept, this is the y-intercept. Your graph supposed to touch the two dots. So you see now I'm able to interpret my graph. Make sure your line is straight, guys. I'm not using a ruler here. Make sure your line is straight. So you see now I have a straight line that passes through here. I have a straight line that passes through here. So my straight line is because my gradient is greater than 0. It is positive. My gradient is 3. Remember, I said my gradient is 3. So that is why my graph, it is shaped this way. So this is how you do it. It's how you draw the graph.